Hey guys, welcome back to another video from the channel Learn from Basics. This is Joe here, and in today's video we're going to learn one of the 6 most popular sorting algorithms that are present. Now, this is our second video on the series on this channel where we learn about competitive programming and some of the topics or algorithms that we'll be using in them. And in this series, we will also be learning or basically solving some problems from past USACO, Code Forces, or HackerRank competitions. Now, the first video of this series, which is finding all substrings from a string via iterations, has already been posted, so make sure you check that out. The link to that will pop up in a card right now and be in the description. Now, today we're going to learn about one of the most simple out of 6 sorting algorithms. Now, why should you learn sorting algorithms, you may ask? Well, the important thing about sorting algorithms isn't the sorting part themselves, but instead, it's the logic behind these sorting algorithms and how you can convert that logic into code. Many competitive programming problems will follow the same logic that some of these sorting algorithms use. Instead, you'll just have to change some of that code from the sorting algorithm in order to meet your usage. So you either add or remove some of that code from the sorting algorithms. So it is good to know these sorting algorithms because instead of refiguring out all of these sorting algorithms on the go, if you need some of their logic, if you already know the logic and know the code, you can simply borrow that code and borrow that logic during your competition, saving you a lot of time. So that's why you should learn these sorting algorithms. And not only that, but this can also be used to show off. I mean, that shouldn't be your main purpose, but just saying. But other than that, just keep in mind that these sorting algorithms, although you won't come along these exact scenarios, they won't ask you to sort a list using bubble sort in a competitive programming contest. Instead, you might use the logic present in one of the sorting algorithms called the bubble sort algorithm whenever you're, dealing with these algorithms. Now, there are 3 simple and 3 complex sorting algorithms. We're going to start off with the most simple sorting algorithm called, the simple sort algorithm. And then in our next video, we're going to go into the select sort algorithm, and we're going to end off the simple sorting algorithm section of this with the bubble sort algorithm. Now, all of these algorithms are simple but not efficient. So the code and the logic behind them are simple, and because of that, they're not efficient. Now, today, as I said, to start off, we're going to start off with the simple sort algorithm. Now, before we start off writing our code for the simple sort algorithm, I like to start off by playing an animation that I've made about how the logic behind the simple sort algorithm works. Now, the simple sort algorithm has 2 loops, an I loop and a J loop. Now, the I loop and J loops both hold an index of this list. So, for example, over here, the index or value of I is 0, so the index it has is 0, and the value of J is 1, aka the index it has is 1. Now, it is important to note that I always starts at 1, and J starts at I plus 1. So J basically equal to I plus 1. Now, one more thing that you have to know is that, these are 2 while loops. And although these, the variable I and variable J do hold the index, so for example, I holds the index of 0 and J right now holds the index of 1. Throughout this tutorial, I'm going to refer to the value of that index as the value of I. So for example, we all know that right now the value of I is 0. But I'm going to refer to the value of I as 5 because the 0th value in this list is 5. So that's just a thing to keep in mind so you don't get confused. But right now, the value of I would be 5 and the value of J would be 2. So now that we have that out of the way, let's start with the logic, shall we? Now, as I said, whenever a program begins, I starts off as 0 and J starts off as 1. Or I starts off as 0 and J starts as I plus 1. So 0 plus 1 is 1. Now, what we do is we compare the value of I, which in this case is 5, and the value of J. We check, is the value of I greater than the value of J, or is 5 greater than 2? Well, according to the basic laws of mathematics, it is. So since our test case works, or since the value of I is greater than the value of J, we're going to switch those values. So the value of J is going to go be the value of I, and the value of I is going to go and be the value of J. So since this is true, we're going to switch those values. So now do you see how it's 2 and 5? Now that we've made that switch, we're going to increment J, or we're going to move J one value to the right. Now, our value of I is 2 and our value of j is 3. Now, is our value of I greater than our value of j, or is 2 greater than 3? Well, it isn't. So we're not going to do anything, and we're going to continue. And by continue, I mean we're going to increment j, and we're going to move on, or we're going to move j to the right. Now, is the value of I greater than the value of j? Well, it still isn't, because 4 is not greater than 2. I'm sorry, because 2 is not greater than 4. So nothing's going to happen, and we're just going to increment j and move it on to the right. Now, is the value of j greater than the value of I? Or is 2 greater than 1? It is. So, since the value of I is greater than the value of j, we're going to switch both of those values again. So, the value of j goes over to the value of I, and the value of I goes over to the value of j. Now, since j has reached the end, since j has reached the last index, we're going to call this the end of iteration 0. Why, you may ask, 0? Because if you remember, in lists in programming languages, our first index is actually index of 0 and not 1. So that's why we have iteration 0 done. And now, do you see how after iteration 0 is done, we have the lowest possible value for the 0th index, because the lowest possible value for the 0th index is 1. So we have one part done. Now that our 0th iteration is done, what we're going to do is we're going to start our first iteration. And to do that, we basically reset the whole thing, and by that I mean we increment I, or move I 1 over to the right, and then we reset j. So we say j I plus 1 equal to j again. So since 0, now I is 1. Now since 1 plus 1 is 2, j is going to be the value of 2. So it's going to be start off at the second index. So 0, 1, 2, that's why j is over here. Now, we're going to do the whole process again. Is the value of I greater than the value of j, or is 5 greater than 3? Well, it is. So, you might have guessed it, we switch those values. And then we increment j, or move it 1 over to the right. And in case you don't know what increment means, it basically means to add 1 to the value. So if you were to increment 5, you would get 6, because 5 plus 1 is 6. And then if you were to increment 6, you would get 7. Just a general knowledge, I guess. Now, let's get back to the topic at hand, which is the simple sort algorithm. So now, is the value of I greater than the value of j? Well, 3 isn't greater than 4. So we're going to say false, and we're going to increment j and move it over to the right. Now, is the value of I greater than the value of j? Well, is 3 greater than 2? It is. So as you might have guessed, we simply switch those values again. So now, the value of I is 2 and the value of j is 3. And you might have noticed that j has reached the last index yet again. So that means we say goodbye and we end the first iteration and begin the second iteration. And to do that, we simply move the I value 1 over to the right, or we increment I, making I 0, 1, 2. And then j again, because 2 plus 1 is 3, it's going to start off at 3. And then we're going to do this again. So, is the value of I greater than the value of j, or is 5 greater than 4? Well, it is. So we're going to switch those values. So 4 and 5, we switch them. And now we increment j. Now, is the value of I greater than the value of j? Well, it is. So we're going to swap those values again. So the value of I is 3 and the value of j is 4. Previously, it was, because we switched them. Now, we say goodbye to the second iteration, because j has reached the last value. Now that we have that done, you might have guessed, we restart the process. So we increment I, or move it 1 to the right, and then we reset j. So again, 0, 1, 2, 3. I is 3. 3 plus 1, 4. So j is going to start at 4. Now, is the value of I greater than the value of j? Well, it is again, because 5 is greater than 4. So since that is true, we're going to switch those over, so 4 and 5. And now you might think, voila, we're done, aren't we? Well, we're actually not done, and that's because although common sense does dictate that this should be the end of our program, what this program actually does is it does go over to the end, and it says, well, basically the value of I and the value of j are going to be the same thing, so it's going to say, well, it's not wrong. So it's basically add one more step, as you can see. Do you see how over here it adds one more step as j and I are both 5, or on the 4th iteration? So yeah, it's going to do that. And then the program's going to say, there you go. That's your program. Now, as you can see, we have a completely sorted list. But let's just go back to the beginning, shall we? Let's go back. Let's get away from all of this algorithm madness. And let's analyze our original list. Do you see how this process could have been much easier if we would have just switched 1 and 5, if we would have just swapped 1 and 5, bringing us the ascending order list 1, 2, 3, 4, 5, right? That would have been way easier. We would have had way less steps, right, guys? Well, that is true, and this is one of the many reasons the the simple sort algorithm is very inefficient, and that's because no matter how good of a case you're given, the time complexity or the amount of time it takes is going to be the same as if you have the worst case scenario. So, if, for example, if I had 1, 2, 3, 4, 5, if that was my list, and I had 4, 3, 2, 5, 1. So let's actually do that over here. So if we had 1, 2, 3, 4, 5, and 4, 3, 4, 2, 5, that random number orientation, both our program would take the same amount of time to arrange this in ascending order as it would take to arrange this. Do you see how in real life you would take way less time to arrange this in ascending order than this, because, well, this is already arranged. So that is one of the many reasons that the simple sorting algorithm isn't the most efficient one, because it just doesn't take advantage of what has already been sorted. But future sorting algorithms such as heap sort, insertion sort, and etc. will take advantage of this situation. And we'll look into those algorithms too. But I hope you guys understand the logic behind the simple sort algorithm, because it is essential if we want to really, master this algorithm and in competitive programming competitions, we want to use these algorithms. So make sure that you watch this video again up till this point if you do not understand the logic, because honestly, memorizing the code won't cut it. So you have to learn the logic. So please do memorize this code. But memorize and understand the logic before you go into the coding part. But taking that into consideration, if you're good with the coding part, then let's start with this, shall we? So I'm going to code in Python because that's one of the most popular and easiest programming languages, and it's also accepted in many competitive programming contests. But please do keep in mind that Python's not the best language for competitive programming. That would go to C++ or Java. But yeah, we're not going to use any Python-specific commands or code, so this should be fairly easy to translate over to another language. So feel free to continue this tutorial with whatever your language of your choice. Now let's start our coding, shall we? And I would actually like to look at this problem from a more of a logical point of view, right? So let's code and let's try to make our code replicate our logic, shall we? So let's do that. Now, as you can see, first of all, our I and j variable is going to go all the way to the end of the list before it restarts or tries to end the program. So because of that, what we'll need to do is we need to find out how long our list is. So to do that, we can create a variable called L, and we can say len of samList, L equal to len of samList, or samList in this case is our sample list. Now, we also know that I starts at 0, right? Because that's just how the simple sort algorithm works. As you can see, let's go back to the first iteration. You can see I starts at 0. So we can create a variable called I and make it 0. And then again, our I while loop goes all the way till the end. So we can make a while loop called while I less than L. So while I less than L, I plus equal to 1, because we do not want this to become an infinite loop. Nobody likes those. But as you can see, we know that so we have our outer for loop done, right? And you might be wondering, well, why do we have a less than over here? Why don't we have a less than or equal to? Well, that's because we all know that this list or lists in programming, their indexes start from a 0 instead of a 1. So this would actually be how our indexes would be calculated. So our last index wouldn't be 5, instead it would be 4. However, the length of this list, according to Python, is actually 5. So that is why, do you see how the last index is 1 less than the length? So that's why we have a less than instead of less than or equal to, because if we had a less than or equal to, our program would access index of 5. But as you can see, we don't have an index of 5, so that's going to throw an error. That's why we said less than. Now, for the j, do you see how previously I said j equal to I plus 1? So our j value, whenever we restart this program, or whenever we reach the end of an iteration, our j value is going to be I plus 1. So that's where our j value is going to start. Again, our j while loop is also going to go to the last index. So we can say while j less than L j plus equal to 1. Because again, we don't want it to become a forever loop. Now we have the loops done. The next thing we have to do is we have to do the comparing and switching. So we know that in order to compare this, we need to compare whether the value in the ith index is greater than the value in the jth index. So to do that, that's also quite simple. We can say if, so again, we can simply say if samlist of I greater than samlist of j. And if so, we need to swap both of those values. Now there's kind of a universal coding, there's a universal coding algorithm, I guess, that is used to switch two values between two variables or list indexes. I'm just going to write down those 3 lines, or algorithm, I guess is the technical term. But I'm going to write down those 3 lines, and you probably know these, but if you don't, then we'll go through them. So let's code them first before I explain them. Equal to samlist of I, and then samlist of I equal to samlist of j, and then samlist of j equal to temp var. So you probably know this, but let's just go through this 3 lines of code real quick. So here's what happens. For example, let's just take this scenario for example, right? Imagine our program is at this point of time. We need to switch 5 and 2. Now, what our code does is, first of all, we store the value of I in temp var, in this case 5 in temp var. And then the next thing we do is we assign whatever value is in j, in this case 2, to the value of I. So we can say, so right now, whenever this line executes, our list is going to look like this, 2, 2, 3, 4, 1. So do you see how we lose whatever value was in I forever if we don't store it in some temporary variable? And since we have to assign the value in I to the value of j because we're swapping them, we need to have that value. So that's why we say temp var, because according to this code, we would have 2, 5, 3, 4, 1. But if over here, if we're gonna say samlist of I, you can see samlist of 0 is 2. So over here, we would have 2, 2, 3, 4, 1, which is not what we want. So that's why we have temp var over here. Now this is all good, but there's actually a faster way to do this in Python. Instead of writing these 3 lines of code, you can do the same swapping mechanism using 1 line of code. I'll just show that off right now. So we can say samlist of j, comma samlist of I equal to samlist of I, comma samlist of j. So it basically assigns samlist of I to j and samlist of j to I. So yeah, this is an easier way to do this, but since I want this tutorial to be like kind of universal or set to all programming languages, I'm just going to leave this to the universal code for this certain task. Now that's it. That is the simple sort algorithm. Now that doesn't look that hard, does it? And that's because it isn't. Simple sort algorithm is one of the easiest algorithms to learn and implement because, well, it's that easy. But it's also inefficient because its time complexity and space complexity is not good. What is time complexity and space complexity? Well, you don't have to worry about that if you don't know it. That's for another video. But just know that if you're ever going to use a sorting algorithm, if you know a better algorithm, which you will learn later on in this course, use that instead of this. This algorithm is mainly used to kind of borrow whenever you need it, but this isn't the fastest sorting algorithm. But with that out of the way, let's see if our program works, shall we? Samlist. Let's run our program, debug it. Does it work? It works, as you can see. 1, 2, 3, 4, 5. And just for confirm, let's do something real quick, shall we? Let's just see if our program goes as we depicted it by printing out every step or each time it gets swapped. Or, well, no, each time it goes to the J loop. Now, do you see how we start off with 5, 2, 3, 4? And then just like we said in our program, it switches over to 2 and 5. And then we go for 2 and 3, nothing happens. As you can see over here, nothing happens. And then we go to 2 and 4, and again, nothing happens. and then we go to 2 and 1, and then these switch. Now if you'll see, if we move over, do you see have 2 and 1 switch? And then again, 5 and 3 switch. You can see over here, 5 and 3 switch. And then 3 and 4, nothing happens. As you can see over here, 3 and 4, nothing happens. 3 and 2, they switch. And then, yeah, so on and so forth. You can see over here, 4 and 5 switch. 3 and 4 switch. 4 and 5 switch yet again. And finally, that's the end of our program. Now, please note this down. Just analyze this and kind of, you'll understand this logic hopefully by now. But as you can see, our program has gone exactly how we wanted it to. Now, guys, I hope you guys understood this. And again, as I said, it's the logic, not the code itself. If you get the logic, it should be easy to translate it into code and use this code in competitive programming competitions whenever you have kind of a same problem or issue. Now, again, that's all for this video, guys. I hope you guys learned something new from this video. And if you did, please do like it. And if you just thought the video was nice, also please like the video. That would mean a lot. If you have any questions, comments, or suggestions to make the series better, please do put them down in the description. Or if you have any requests for any videos or concepts, also put them down in the comment section so I can get to them. Again, that's all for this video. I hope you guys liked it. All useful links will be down in the description, and all the links that I've talked off will also be down in the description. And if I can get this animation to be shareable, I'll also put that down in the description so you can access this animation. But that's all for this video. If you guys did like this video, don't forget to leave a like. Also share this with your friends so your friends can learn this cool algorithm. And then also subscribe if you haven't, and turn on notifications because, why not? I mean, there's a lot of great videos that are coming up on this channel. And if you want to learn more about programming and more concepts like this, please do go ahead and subscribe. That's all for this video. If you guys like this, again, as I said, like. See you guys in the next one. Bye-bye.